Hello, the Four Fox. Just in time for statistics. I can't actually pronounce the word statistics easily. I have a lot of trouble with that word, so I try not to say it, but it comes up a lot, especially in the workplace. Statistics. Also, Google. Google. I can't say the word Google. And I interviewed at Google once, and I was worried because I was worried they'd notice I can't pronounce the name of their company. All right, start this paper. So, hang on. Let's get the timer up. Okay. Oh, I need to plug in my pen. All right, so make sure my pen's working. I should have done this before the stream. Okay, two as always. I need to come up with a signature. All right. Make sure we got the right paper. Statistics, higher tier, paper 2. It's 1 hour 45 again. I was actually pressed for time on the last paper. I was working. I finished just like seconds before the time went out. I thought I would have loads of time, so it's actually quite tight. But then I'm trying to work with a Google calculator, which I'm not really good at. I would much rather have a physical calculator, but I don't, because who has a physical calculator in this day and age? All right, so same as before. Let's just begin. Oops. Okay. All right. It's showing up on stream. No problems. Why am I nervous? This has brought me back. This has brought me back to my GCSE days, where your whole life depends on this. No, actually, it doesn't. Not GCSE. A levels is the next exam you do. Your whole life does actually depend on that. Like A levels is where you know you either get your university choice or you end up working at McDonald's. All right. Why is the timer not working? Oh, because num lock. There we go. All right. Vanessa measures the height and mass of 12 children. Circle the name given to the type of data she has collected. Height and mass, two separate things, right? They're both quantitative. It's not categorical. It's not discrete. It's not qualitative. So I guess bivariate. Yeah, it's bivariate. It is. They have independent distributions. So okay. McDonald's is nice, probably. Wouldn't know. Can't remember the last time I ate there. I go there sometimes to grab an espresso, sorry. Here in France they call it expresso, which I hate because, I don't know, it's a mispronunciation that some Brits make. But I've never ever ordered anything other than an espresso since I was a kid. Right, a set of 16 data values. X has, okay, sum of squares, I remember this. Circle the standard deviation of the data. Use. So you divide that by n. So 36 over 16. And then square root it, right? So it'd be 6 over 4. So 0.5. Tree diagram shows some probabilities relating to events A and B. Circle the probability of B given A. Circle the probability. Okay, so B given A. So 0.4. A is here. Yeah, 0.4. Circle the probability of B and not A. So that's not A. So it'd be 0.2 times 0.7, which is 0.14. Modal age of buildings in each region of the town is shown. Modal age, so the most common age? Okay. Circle the modal age of the buildings in region F of this town. Well, it's 20 to 39. That's barely even a statistics question, is it? It's just read the legend. Alright. The key. Read the key. The oldest building in the town was built in 1847. Ahmed says that this building is in region J. Is Ahmed correct? The oldest building in the town was built in 1847. It's irrelevant. Because we don't know how many. It's modal. It just means the most common. Modal is the most common age. A single data point could be in any region without affecting the mode. Right? Yeah. Also, it kind of matters what year is this. Well, it's less than 60 either way. Okay, so the diagram below shows the modal age of buildings in a neighboring village. Compare the age of buildings in the village with the age of buildings in the town. They're older. It's not older on average, but on the modal. Alright, so the village appears to have many older buildings. the... What more can I say than that? Okay. A town council is considering reducing the opening hours of the local library. Grace and Alex want to find out how many people living in the town feel about this. Grace decides to ask people as they leave a supermarket in the town at different times one week. She collects data from 30 males and 30 females aged 40 years and under, 30 males and 30 females aged 41 years and over. What is the name given to this type of sampling? God. I don't know. I just remember one type of sampling, stratified sampling. I don't remember what it means. I don't think it's stratified. Well, they mentioned categorical earlier, but that's data, not sampling. Like, what other sampling is there? Stratified? Selection sampling? Is that a sampling? Selection? Stratified is where you... I don't even know if selection's a real sampling. Let's just say stratified. It's not going to be the answer, but at least it's an actual sampling method that I can remember. I don't know if that's the one. Hi there, 4Fox. You missed 4 questions, I guess. The first 8 minutes. Not terribly interesting, just lots of 1-mark questions. Give 2 different reasons why her sample may be unreliable. I mean, it seems like she is doing picking a good sample, and why would her sample be unreliable? Because I mean, she's covering males, females, age. Maybe, okay, should we say something about kids? Because kids are the ones that use libraries the most, aren't they? Her sample may be underrepresenting kids who are major users of libraries, surely. I mean, I don't know about other countries, but in the UK, it's pretty much only kids that use libraries these days. What other reason would a sample be unreliable? People shopping, because she's picking them from a supermarket. In a supermarket may be... What am I trying to say here? People shopping in a supermarket may not... Is there any logic to this? I'm spending too much time on this. Let's just say people shopping in a supermarket may not be users of the Library. Why isn't she checking people as they leave the library? Okay. The town has 8,000 houses. Alex decides to obtain a sample of 120 of these houses using random sampling. Explain how Alex can use a list of random numbers to select his sample. Okay. Alex, should I type this? How do we do that? Okay. Alex produces a sequence of random numbers from 1 to 120 for each no to 8,000 120 random numbers from 1 to 1,000. Each number presents which house to pick. If he gets a repeat, he can discard that number and pick a new random number in the sequence. This method ensures a uniformly random sample. Selects a sequence. Oh. But what form are they giving us? Okay, I don't know what form they're giving them. If the random number is a float between 0 and 1, multiply by 8,000 and round to get the ID of the house. I don't know what random numbers they're giving us. Okay. Alex plans to interview one person face to face from each house he samples. Write down one problem that he could have when he tries to carry out the interviews. They may not wish to be interviewed. One way that he could overcome the problem: bribe them. I mean that quite literally. Offer them a financial incentive that wouldn't overcome the problem, but it would help. I mean, you just have to offer an incentive, e.g. prize draw or a voucher or something. I mean, otherwise I would say just interview more people, but this is good too. Mean number of portions of fruit and vegetables eaten per day by children and adults of different ages and gender in England. Compare the amount of fruit and vegetables eaten by males aged 14 to 15. So it's here, so we got this one. 2.9 versus 3.2. On average, can't write the word. Average females eat more fruit and veg. Right, 2 comparisons of the amount of fruit and vegetables eaten by different ages of adults. What? Okay, just say 2 things about the data, right? 'They say specifically different ages. So they care about gender? So 16 to 24 eat the least on average. And that's both genders. Should I just say, so it's 65 to 74. 65 to 74 eat the most on average, both genders. So that's 2 comparisons, right? Natalie wants to investigate how many portions of fruit and vegetables students in her year group eat at school eat. Year group at school eat. Okay. So this is stratifying. Natalie decides to interview a sample of 40 students. So the sample above wasn't stratified sample. I need to replace that. Okay, explain why it is sensible for Natalie to stratify. Stratifying maintains the ratios, the gender ratios, which reflect the population. But that Natalie should select 18 male students from her year group. So it's what, 99 out of 99 plus 121 times 40 equals 99 to 20 is 40. That's 20 so it equals 30. So 9 times 2 equals 18. Natalie's friend suggests that she should interview students in her year group eating school dinners. Explain why this could give biased results. How many portions of fruit and vegetables students in a year group at school eat? Oh, because they could be eating students. Can't write. Students who bring packed lunches from home are not represented. And they may be eating healthier meals because their parents are... Oh, so let's go back and change one of those answers from before. This one, stratified. It's not stratified because that is not stratified. Uniform? I can't even think. Let's say uniform. All right, Natalie decides to select 18. How many portions of fruit and vegetables did you eat yesterday? It is recommended that everyone should eat at least 5 portions of fruit and vegetables every day. Calculate an estimate of the percentage of students in Natalie's year group that ate at least 5 portions. So we've got 5 here, and we've got 2 here, so 7. So 5 plus 2 equals 7. At least 5 portions. So 7 out of 40 equals, first time I'm using the calculator, 7 divided by 40, 0.175. So 17.5%. Students in Natalie's year, oh god, this is an essay question. Oh, no it's not, it's a calculation. Students in Natalie's year are aged 14 to 15. Compare the number of portions of fruit and vegetables eaten by students in Natalie's year with the corresponding figure for England. You should use the information from bar line graph on page 10 and the information from the table on page 8 to calculate the appropriate average. So 14 to 15. So England is 3.0. England 3.0 average portions, and from Natalie, so it's Okay. So it's 6. So it's 6 times 0 plus 4 times 1 plus 10 times 2. 4 times 1 plus 10 times 2 plus 9 times 3 plus 4 times 4 plus 5 times 5. 9 times 3, 4, 4, 5, 5. 9 times 3 plus 4 by 4 plus 5 by 5 plus 2 by 6 equals 4 plus 20 plus 27 plus 16 plus 25 plus 12. What do we got? Equals, we got 24 plus, we can add these together, we get 53 plus 37 equals, we got 67 plus 37 equals but if I, oh no, because you need to divide by 40. Okay, yeah, so it's 104. 104 divided by 40 equals 2.6. Not too bad, not too far off. So let's suggest 2 things that Natalie could have done to make her comparison more reliable. Oh, I need to compare. So Natalie's students eat slightly less than the national average. Make a comparison more reliable. To make a comparison more reliable. So what, change the data, or using the data, well, we're the ones comparing. I don't know. Pick a larger sample. That's always an answer for making it more reliable. Any stats whatsoever, pick a larger sample. What else? Suggest 2 things that Natalie could have done to make a comparison more reliable. Ask students for an average over the week, or repeat on different weekdays. Because if you ask on a Monday, they're going to say what they ate on Sunday. And that might be different from what they eat at school, because Sunday they'll be at home, so... Small pottery factory has 2 designers, Lucy and William. The factory makes 3 types of pottery: vases, jugs, and teapots. Use the information in, oh yay, Venn diagrams, I love these. All right. Venn diagrams are great. So we've got 9 step. Oh, okay. So Lucy, number of items of pottery made by. Okay. Wait, I don't understand this. Oh, I see. Yeah, I get it now. Okay. 970 is all different things made by different people. L is Lucy's items. V is vases, which may be made by either person. Okay. So if we want to, it's the intersection would be L and V. So it would be vases made by Lucy. So 3, 2, 5. And vases not made by Lucy would be 250. And Lucy's items that are not vases would be 155. And then everything outside would be neither Lucy nor vase. So it would be jugs and teapots made by William. So 240. Okay. 3 marks. Okay. The pie chart represents the items of pottery made by William in 2019. Okay. William made 312 vases in 2019. Did William make more teapots in 2019 than in 2018? Alright, well, let's work these numbers out. So we got here it's going to be 360 minus 294. Which is 66. So 208 out of 360 times T equals 312. So we want to find T, which is the total. So T equals 312 times 360 out of 208. Is that right? So it's that proportion out of the circle multiplied by the total, which is unknown. Is it? Yeah. We get 312. Okay. So 312 times 360 over 208. $540. It's a nice round number. So number of teapots equals 66 out of 360 times 540 equals 66 times 540. $99. And in 2018, 95. So the line graphs show the expectancy at birth of males and females in the UK and Brazil. So Brazil is much less life expectancy overall at all ages. Not terribly surprising. And in both cases, females have a fairly significantly increased life expectancy. I suppose not surprising, but depends really. Okay, I mean, still, traditionally, females tend not to work in the more dangerous roles, like military, heavy industry, stuff like that. But females also suffer from health problems that are more common in females, like pregnancy complications, cancer, breast cancer. So I wouldn't really know. But apparently, according to this data, it's females live longer. Okay, I can believe that. I would have thought the distinction would be larger in Brazil, though. It does seem to be. Well, okay. Compare life expectancy in the UK and Brazil. Comparison of life expectancy in the UK and Brazil. Oh God, right. Okay. Life. Let's just use a text box for this, all right? So. Damn it. All right. Life expectancy in UK is noticeably larger than that of Brazil across all years and genders. That's bullet point 1, because that is the case, right? I can't see any point where it's 70, where it's Brazil wins. UK is very clearly higher. Between the genders, females appear to have a larger life expectancy overall in both countries. In UK, they are steadily about 4 to 6 years higher than males, whilst in Brazil, they start about 4 years higher in 1960, but eventually the gap increases to about 7 years. Interesting. Why is the gap larger now than it was in 1960? I would have thought the other way around. Okay. Comparison of the trends in life expectancy over time. Overall, life expectancy in both countries has increased with I wouldn't want to say linear. Overall life expectancy has increased over the years. In UK, the increase seems to be of a slightly higher degree than linear, whilst in Brazil the increase is roughly linear. What more can you say about this? From 1960 to 1970, from 1960 to 1970, there is a distinctly rapid increase in the life expectancy of females whose incline is higher than all other sections of the graphs. It would be of interest to investigate what happened in this decade. I don't know. What more do you want me to say? 5 marks. I've got to say 5 things, really. What else do I want to say? Do I have to give reasons? This may be because UK has more developed healthcare and economy. The reason for females living longer may be due to traditional female gender roles in industry, such as military, heavy industry, etc. The increases may be due to improved economy and healthcare in both countries. So this doesn't include the war, does it? Don't mention the war. No. Interesting, there's no dips. Like there were yeah, I guess there wouldn't be. Alright, I've said a lot of things, I don't know. The table shows some of the index numbers for the average prices of houses in different... The base year is 2015. Explain why the weighting for England is greater than the weightings for the other countries of the UK. England has higher population. The average price of a house in Wales in 2016 was 177,000. Calculate the average price of a house in Wales in 2017. I don't understand these index tables. What does it mean? Well, anyway, I'll just take one. Okay. I'm just going to assume you do this. 105.2 divided by 101.7 times 177,000 equals 105.2 1.7. So 183,091. 183,091. One 83091. So we got about an hour left. Calculate a weighted index number for the price of houses in the whole of the UK in 2017 using 2015 as the base year. I don't understand this base year stuff. The whole of the UK in 2017 using 2015 as the base year. Okay, but even if I don't understand the base year, I can probably work out using ratios. Using 2015 as the... So they already used 2015 as the base year, so we're fine there. So we want 2017. I see. So it'll be 105 points. Oh, so you basically average them, but using that average. So 105.7 times 84. 105.7 times 84. 7 times 84 plus 105.2 times 4. 105.2 times 4. 100.6 times 10 plus 100.6 times 10. 103.4 times 2 plus 103.4 times 2 all over 100 equals, God, okay, 105.7 times 84. 7 times 84 plus 105.2 times 4. Where am I typing this? Whoops. 105.2 times 4. 105.2 times 4. 103.4 times 2. $105.124. $105.124. Should I round it? I'll just put all the numbers. The table average price of a house in London 2015 and 2017. That's pretty cheap. Going by today's standards. All right, a newspaper claims that the average price of a house in London has increased by a greater percentage between 2000. Okay, so London. 3/499. $543/499. $108.82. What? 1.0882. 1.0882. So 8.82% increase. UK. So we've got $105.124, but this one's clear because it's the base year, so it's 5.124% ink. So newspaper is correct. Plaque is a sticky substance that forms on teeth. Tim cleans the teeth of 10 of his patients by removing all their plaque. He asks these 10 patients to record the length of time they spend cleaning their teeth each day of 2 months. At the end of the 2 months, he calculates a plaque score for each patient's teeth using a 0 to 3 continuous scale. No plaque, 1, 2, and 3. Write down the response variable. Huh? What's response variable? It's what they say. Length of time spent cleaning. Tim gives each patient a diary to complete so that they can record when and for how long they clean their teeth. Why might this be a good idea? Because without a diary, they may be more likely to forget to record or may misremember. Write down 2 different problems with Tim's line of best fit. Gradient is too shallow. Should be steeper. To fit the data. Line should be longer, right? Be longer to reach x equals 0 and x equals 6, because it should be. That's how you do lines of best fit. Ellie, another dentist, is on. The equation of her line is y equals 2.7 minus 0.43x. Okay. Average time spent brushing per day. Is that what? Yeah. Ellie suggests that her patients should brush their teeth twice a day for an average of 2 minutes each time. Okay. Estimate the plaque score for a patient who follows Ellie's advice. All right, so 2 times 2 equals 4 min per day. So y equals 2.7 minus 0.43 times 4 equals, we'll do this in our heads. No, I can't be bothered. 2.7 minus 0.43 times 4. 2.7 minus 0.43 times 4. 0.98. 0.98. So that's not too far off Tim's. Ellie collects her data from 12 patients. Calculate the value of Spearman's rank correlation coefficient. Well, they've conveniently completely spelled it out for us. So RS equals 1 minus... I used to like Spearman's rank. It's pretty methodical. It's 520. But I only really did it in geography, not in stats. 12 times 143. All right. 6 times 520. 6 times 520 divided by 12 times 1.3. One minus, so it's minus 0.818, minus 0.818, minus 0.818. So that's strongly negative, which is what we'd expect. Tim collects plaque data for some different patients. Record the average time they spent showering each day. Spearman's rank correlation for this data is minus 0.76. People can reduce their plaque score by spending more time in the shower. No. Here we go. Now we have to word this properly. God, let's just first repeat the mantra. correlation, not causation. Shower time may be strongly correlated with brush time, e.g., if someone is more hygienic. What more do I need to say? But no causality. All right, hopefully I get them all. Flu vaccination rates. Oh, okay, now we're talking. Flu vaccines. I wonder if the anti-vaxxers would refuse to answer these questions. To be fair, if an anti-vaxxer were to be good at statistics and pass the statistics GCSE, they probably wouldn't be an anti-vaxxer, would they? They would actually understand the statistics. Okay, flu vaccine, number receiving divided by number offered times 1,000. Okay. Okay. So we got 113,100 divided by 188,500. 113,100. 113,100 divided by 188,500. 0.6. So 600. So it's a number, but so it's, they just like to multiply by 1,000 just to make it out of 1,000. It's a bit weird. Why not 100? Then it's like a percentage. Okay. The flu vaccination rates in Greater Manchester and South East are equal. Okay, so that's also 600. So then what we got? 171,800 divided by x equals times 1,000 equals 600. So x equals 171,800 times 1,000 divided by 600. 171,800. 171,800 divided by 600. 286,333. 286,333. 286,333. All young children offered MMR. 91% of young children in England receive the vaccine. Yeah, I remember having that. A childminder in England cares for 4 young children. Write down one assumption that must be made. Number of these children who receive the MMR. Independence, which clearly is not going to be the case here. Children's vaccine status must be independent of other children. And if you're caring for children, then there's not going to be independence, is there? Assuming this binomial distribution is appropriate, okay, calculate the probability that at least 3 of these 4 children receive the MMR vaccine. Okay, probability of 3 equals all right, I gotta remember this stuff. So at GCSE level, you use this NCR. At university level, you do this N. So using this one, I guess, because it's GCSEs. So we do 4 choose 3 times 0.91 to the 3 times 0.09 to the 1. Is that it? Okay, let's do that. All right, so 4 choose 3 will be 4. So it'll be 4 times 0.91 to the 3 times 0.09. 0.271 equals 0.2713, let's say. 2713. Probability of 4 equals 4 choose 4, so that's 1, times 0.91 to the 4 equals 0.91 to the 4. Zero 0.6857. 0.6857 plus these together plus 0.2713 0.957. Hopefully I got that right, and that's a nice 4 marks there. That's a proper binomial distribution question. That sounds about right, because you'd expect it'd be very rare for it to fall below. Laura randomly selects 250 young children attending nursery school. Okay. 230 out of 250 equals 230 0.92. 0.92. Children in this city are more likely to receive the MMR vaccine than children in the whole of England. What was it for the whole of England? Laura has focused only on, hang on, nursery schools. Hang on. Let's say 0.92 is not much larger than 0.91. Perhaps larger sample should be taken to ensure higher confidence. And this is e.g. use the student's t-test. That's what you use, right? Student's t-test or the chi-squared test? I think t-test. A trout is a type of fish. Gemma wants to estimate the number of trout living in a lake. She captures 138 trout from the lake, marks these trout and releases them back into the lake. Captures a second sample of 95 trout. She finds that 23 trout from the second sample are marked. Calculate an estimate of the number of trout in the lake. Wait, what? Oh, interesting question. Okay. So we say there's n trout altogether. So 138 out of n are marked. So estimated probability of trout being marked equals 138 out of n. Okay. So now the probability hang on, so is this what do you do here? This is a bit, the actual probability will be a bit confusing to come, but they're saying estimate. So I think, okay, from 95, expect 138 out of n times 95 equals 23. Therefore, n equals 138 times 95 over 23. 138 times 95. 138 times 95 divided by 23. 570. Suppose it makes sense. As long as the sample you're picking is significantly smaller than the whole population, then that's the correct calculation you need to use without replacement, which is problematic. Why does Gemma wait 1 week before she takes allow the marked to evenly disperse in the lake? Should we throw in the word homogeneity? Can't even spell it. Unity. Gemma measured the length of the 138 trout she captured in her first sample. Okay. Histogram, alright. What mistake has Gemma made in drawing her histogram? So we got 0 to 20, 18. Oh, damn it. She has used freak instead of freak density. Draw a correct histogram to show Gemma's information. This is the final question, and we've got enough time. Okay, fine. So we need the density. So how to do this? It's 18 over, so it's divided by the width, right? Equals 0.9. So 30 over 10 equals 3. 38 over 10 equals 3.8. 30 divided by 20, 1.5. 14 divided by, okay, so let's say frequency dense. 14 divided by 20 equals 0.7. And 8 divided by 40. Yeah, which is 0.2. So we go as high as 3 to, let's say, up to 4. So let's say this is 1, 2, 3, 4. Oh, how convenient. So it's numfish per centimeter. Okay, and on the bottom we've got the same as before, so we want 120 over here. So it's like 20, 40, 60, 80, 100, 120, okay. 20, 40, 60. I can't see the slightly thicker lines, it's not very clear. All right, and this is length. Centimeters. Okay, so now we want 0.9, 0 to 20, 0.9. So like, okay. And then we want 20 to 30, 3. This is a pretty good question overall. I used to hate histograms because I'd rather calculate like a formula or something. And you have to get your ruler out and stuff, but they're actually pretty good. They're pretty cool. 3.8, 30 to 40. .5 to 40 to 60, 1.5. .60 to 80, 0.7. And then we've got 80 to 120, 0.2. What type of skewness is shown in the histogram measure B part 2? Skewness? Oh god, what is this? What? How do you classify skewness? How would you even, I don't know. Left? Because it's tending to the left? It's just one of those terms that is specific to GCSE. I would just say left. West? Left? I don't know. Type of skewness. Why would they give it a name other than left or right? Left tells you exactly. Left was tending towards lower lengths, so I don't know. Left to me is the clearest word. Alright, do we want to check out? We've got 20 minutes left. I can't be bothered to check my answers. I feel much better about this paper. We can have a quick look by variance. 604. B given A. 6.4. And not 8, yeah. That one was easy, and then village appears to have many older buildings. Sure. Do I want to say more? No, I'm fine with that. Uniform? I don't know what to call that sampling. But there was one question I was a bit worried about. Which one was it? I'm fine with these ones. I wrote a lot there. Just higher population. It's the I have no idea what index tables are. That's new to me, and it came up in the previous paper as well. But I think I've made a good educated guess about how to answer the questions, even though I don't know what an index table is. So I've kind of just kept the ratio, and I think it will be correct. So we'll see. So I'm not worried about that really. Left skewness. Positive? No, because positive would be... I don't know. I don't think positive and negative have meaning here. It's just whether it tends to the lower... I don't know. Alright, I'll just finish there. Time to mark. Alright, I think I did better in this paper than I did in yesterday's paper. And if that's correct, then that means I'll get the top grade, because I was already just above the top grade boundary for the first paper. So if I do better in this paper, then overall the top grade is secured. We'll see. All right, let's have a look. All right, we've got bivariate 1.5, 0.4. .14, 20 to 39. Cannot tell. Yeah, that's basically what I said. The village appears to have many older buildings, is what I said. Yep. Yeah, older. Older being the operative word here, so yeah. Okay, sampling. Quota. Yeah. Alright, let's make a note of these lost marks. Or lost 1 marks there. Quota. I mean, I see how the word fits. You have a quota, a fixed quota for each category, gender, for example, where you don't care that there may be more females than males, for example. That's one way of doing it. I just don't remember those terms. All right, sample maybe underrepresented. Oh, no, let's see. People using supermarket may not all live in town. People problems connected with bias towards people who visit that once. Some. Okay, trying to make sense of this. The age profile of supermarket shoppers may not be the same as the age profile of library users. There's an alternative type 3 reason. Well, that's kind of what I said. But I was picking on kids. But they have mentioned age. So I reckon I've covered the age mark. But I think that's a big problem, what I've mentioned. Alright, the other one I said, people shopping in the supermarket may not be users of the library. Yeah, look, I've said younger people may not be represented. She only sampled 1 week. Oh no, but these... I don't even agree with my own reason to. Because whether or not they're users of the library is not the point. The point is their opinion on the opening hours of the library. So people who don't visit the library still have valid opinions on this. because it won't affect them. So that's actually a positive in favor of reducing the hours. All right, I'm gonna make a judgment call. We'll give myself 1 mark for that. All right. Assign a number to every house in the town. Select 120 numbers, ignoring repeats. Yeah, that's what I said, basically. If you get a repeat, discard that and take a new number. Select the houses matching the numbers chosen. Yeah, I think what I wrote was fair for that. Sure. Alright, they may not wish to be interviewed. Yeah. Offer an incentive. C2. Give an incentive. Yes, I used the exact word. Incentive. Alright. 2.9 versus 3.2. Females eat more. Yep. 16 to 24 eat the least on average. Yeah, both of mine were mentioned. Okay. Stratifying maintains the gender ratios which reflect the population. Proportion of males in the match the population. Yep. Happy with this so far. Yep. Students who bring packed lunches from home are not represented. Yeah, that's what I said. People who do not eat school dinners probably bring lunches from home. Okay, 17.5. Yes. Right, 5 marks here. So England got 3.0. Yeah. Got 104 divided by 40 to get 2.6. Students eat less fruit than students in England. Yes, all 5 marks. All those points were mentioned. All right, suggestions. G. Bigger sample. Always an answer. When in doubt, just say bigger sample. Ask students for an average over the week. Yes. All repeat on different weekdays, yeah. Oops. All right, 155, 325, 250, 240. Yep. Okay, B. More in 2019 is what I eventually said. Yeah, 99. 208 over 60, blah, blah, blah. Yeah, I've got all those elements. Yeah. All right, the Brazil and the UK one. Oh, there's a lot of marks to be gained here. 8. It's just 8. All right, the life expectancy of the UK is higher than in Brazil. Yep, I said that. Gender difference. Life expectancy for females higher than males. Yep, said that. Difference in land is smaller in the UK than in Brazil. Or difference in life expectancy. Yes, I said widened for Brazil. Okay, I did say that. Life expectancy have increased. Yep, I said that. Increased at a faster rate than the UK. I didn't say that, but hang on. So I got 1, 2, 3, 4 so far. They're giving you a mark for saying life expectancies in Brazil have increased at a faster rate. I didn't quite say that. (1969 70) is distinctly rapid. Is inclines. 4. I think I got 4 out of 5. Apparently they want you to say these very specific things. And I didn't say that life expectancy in Brazil have increased at a faster rate than in the UK. OE. Or equivalent is what they mean, but I don't think what I said was really the equivalent. Okay. I'll take it. 4. I mean, even if you're good at stats, you can never know what they have written down there. You just got to say lots and lots of things. Those remaining 20 minutes I had, I could have just written loads of bullet points and probably would have got the 5. 9A. England is higher population. Yep. 103091. Yeah, between 048 and 100. Okay. Why have they got a long-winded way of doing this? I'd argue that their method here is unnecessary. So I've gone straight from 2016 to 2017. They've gone from 2016 to 2015 and then 2015 to 2017. I'd argue that the hundreds cancel out, so you don't need to do that. Do they? So I've said 177 times 105.2 over 1.7. They have 77 times 105.2, yeah. Divided by 101.7. Yeah, mine is just a simplification of that. And I have both elements they're saying. It's all encompassed by the fraction, so I don't think I lose marks there. I think that's fine. I just cancelled out the hundreds, because why would you keep the hundreds in? I don't know. The examiners could be a bit fussy, and at most I would lose 1 mark there, probably. But I see no reason to separate this into 2 equations. This is completely logical to me, so I don't know. 105, 124. Yep. Newspaper is correct. 8.8%. 540 over, yeah, so 8.8%. Yep. Oh, on a roll. I haven't lost many marks. Only 3 marks so far. 10. Plaque score. Damn it! What does response variable mean? I don't know. Because I thought response variable is the response that your patient gives, but I suppose it's not. Response variable. Oh, they've changed the names, haven't they? So in my day, it was dependent and independent variable. The dependent variable is plaque score. The independent variable, the one that you can control, is length of time spent cleaning. It seems they renamed them to response variable and something else. Oh, why'd they rename it? All right. To help them remember. Yeah, that's what I said. Line does not pass through the double mean point. I didn't think about that. Horizontal extent of the data. I did say that. So that's that one. It's not gradient they were getting at. It's where it's centered. It should be centered around the mean. I didn't say that. I said too shallow. Gradient is not the important point here. It's too high up is not even... Alright, I lost 1 mark there. Okay. Alright, 0.98. Minus 0.818, yep. Okay, no. Correlation, not causation, blah, 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 something along those lines. No, correlation does not imply causation, yes, right. Alright, 600. So 286, 333. Okay, yep. BI, independence. Independently, yeah, that's it. BII, 0.957. Oh, there's a lot of reasons here, okay. Yep. Yep. That was a good question there. That's really testing that you know your stuff with binomial distributions, which is important. It comes up in real life. 0.92. Hang on, so we've got 11C. So we've got 0.92. So I got 1 mark. Yeah, that's what I said. It's not much bigger than 91%. Also, nursery schools. I don't know, what's the alternative to nursery schools? But yeah, no, it's only 2 marks. I did say trout. 23, 570, yes. I wasn't sure what they were getting at there, but yeah, I see what. That was a good question actually. I don't know if they're taught to do this type of question or you were supposed to improvise. But if it's to improvise, I'd say that's a very good question. It keeps you thinking on your feet. Because you have to use intuition to make pick the right distribution. Okay, so homogeneity. Yeah, mix. They use mix. I use homogeneity. The histogram. All right. All right, 4 marks here. That looks picture perfect. I even put the units. They didn't put the units for density. Yeah. The answer to this was positive? Damn it, I should have just written positive. Of course, it's not going to be left. What does positive mean then? Tending towards the left? Because why would you call that positive? There's nothing positive about it. It's just tending towards once, I don't know, tending towards lower. It just means that I don't know. All right then. So I lost 1, 2, 3, 4, 5, 6 marks altogether. Wait, was that right? I don't know if I added that mark. So we got lost 1 there. 2, 3, 4. 5, 6. Yeah. So I lost 6 marks, so I got 74. So in the first paper I got 69, and here I got 74. So my total is 143. So 160. I know for a fact that that is grade 9, the highest grade. The grade boundary for grade 9 in this year, because they have different boundaries every year, it's somewhat curved. But the grade boundary was about 130 something. So we did it. No. Well, there we go then. Okay, let's put that in our chart. So I got 143, and that's a grade. Damn it, I have to put the cell borders on. Okay. So far I've got top grades and everything, but those were the 3 that I was predicting top grades in. So, and computer science was a close one. So, it's gonna go downhill from here. The next one I'll probably do is physics. I've predicted 8. I could get 9. I just don't know what comes up in GCSE physics. If there's any weird stuff that I don't remember, then I might lose marks. But I mean, I can change my prediction now because I've not seen a physics paper yet. So do I want to go with 9 or 8? GCSE physics. Should I go for 9? To be ambitious. I mean, I should be good at physics, but it's just there's a lot more knowledge, fewer or less reliance on calculations, even though there are lots of calculations. Do I take this? How do I? Oh my god, I hate the cell borders thing. Okay, now please put the border on the bottom one and on the right. There we go. Oh, now this one's missing a border. That one goes. All right, 9. Should I go for 9 then? Yeah, let's be confident. I'm gonna go for 9 for physics. All right, but on the whole, I was actually quite impressed with this paper. I'm actually very happy that kids are getting taught this level of statistics at GCSE level, because this is all very useful stuff in the real world. It really is. Like understanding correlation and causation, how to interpret data, healthcare stuff. There was stuff about vaccines there. If you understand this GCSE, you understand better than all these anti-vaxxers when it comes to you know, vaccine statistics in general. So this is a really, really good GCSE. I would argue more useful to real life than maths. It pains me to say that because maths was my all-time favorite subject, but this is actually more useful. And when they ask you to give reasons for correlations or to interpret data, that is all very useful as well. Especially if you work in business, I mean, you have to do that. See, I'm surprised that this is such a new GCSE. This should have been available a decade ago. There's no reason for it to be new. I mean, business, industry, statistics, this all existed decades ago, so why have they only introduced it now? Okay, enough. Well, the next time I do this in a few days, probably, I will tackle physics. I'm worried about this. I still have up until that day to change my prediction to 8 if I want to, but I won't go any lower than 8. I think 9 or 8. Low 9. I think low 9, because that's what I got for computer science. All right, well, that was GCSE statistics. I'm wondering if I should do this next year. No, next year I'll do A levels. All right, well, see you later.